Hello, everyone, and thank you for joining today's session. My name is Reese, and I'll be a moderator today. We are going to get started at the top of the hour. If you have just joined us, please make sure that you have registered for this session. That means we can send you the recording and the resources as soon as this is live on our resource center. If you haven't registered already, there is a link to do so in the chat. If you're on YouTube, you can find it in the video description, and you can also scan the QR code that's on screen now. You can also head over to datacamp.com/webinars, where you'll find this session as well as all of our future sessions as well. We have Data and AI Literacy Month coming up, which is the entirety of September. So please do check out all of the sessions that we've got going on for that. It's going to be very, very exciting. In terms of today's session, though, there are a few prerequisites if you'd like to code along with us live. The details of these are in the resources document that I will post very shortly. If you're on YouTube, this is already in the video description and pinned in the comments. If you're watching on LinkedIn, please check the comments because I'll be sharing it again now. But yeah, I'll be posting it again a few times throughout the session. So yeah, if you do want to code along with us live, there are a few bits of setup. Namely, you need to have, give me 1 second, I've lost my own document. This is embarrassing. Namely, you need to have the GitHub repo that is linked in the resources document. You'll want to have AWS CLI, Git, or Docker. You'll need an AWS account with access keys for the deployment from CLI. You'll need Terraform or CDK. You'll need Node.js installed, and you'll also need access to a particular area, but all of these details are in the resources document. So rather than listen to me butcher it, please do check out the resources document. The resources document is in the video description if you're on YouTube, and if you're on LinkedIn or Facebook, I'll be posting it as a comment very shortly, which you'll need to copy and paste out. So yeah, please do check out the resources document if you want to go along live with us. However, we are going to be running through everything at the start. We've got a few slides to run through as well. So everything you need is in the resources document. Please do refer to that as your source of truth for today's session. However, if you want to go along live, but it's not working for whatever reason, please make sure that you register for the session, and we will send you the recording once it's live on our resource center, and you can catch up in your own time as well. If you have any questions at any point throughout the session, let us know in the comments. We're going to be running through your questions for the last 10 minutes of the session. So let us know, and please do stick around. So for anyone that's just joined, thank you so much. Okay, I think we might have lost me there. I think that's probably my time to get the rug pulled. So I'll now hand you over to your host for today's session, Richie. Richie, please take it away.
Hi there, data scamps and data champs. This is Richie. We're doing smooth handovers here. All right, so please do let us know where you're joining from in the chat. Always nice to see where our audience is from. And you know what? I'm just going to kick things off. So creating AI agents is the hottest of hot topics, but as well as building your agents, you also have to find a way to serve those agents to your users. And of course, the natural way of doing this is by putting your agent on the cloud. So today we're going to be learning about building and deploying AI agents on AWS. So AWS is absolutely huge. I have to confess, I tend to get lost in it. There's so many different services. So today we're going to learn a little bit about which AWS services you need in order to make AI agents. We're also going to spend some time thinking about architecture of AI agents and, of course, how you go about getting them into production. Our guest is Sowjanya Pandruju. She's a cloud application architect at AWS, so going straight to the source. So hi, Sowjanya.
Hi, Richie. Nice to meet you.
Yeah, great to have you here. Sowjanya helps customers architect and build AI applications on AWS. She's got a decade of experience in software engineering and also AI. Very convenient to have both these skills. She's also a senior member at the IEEE and previously Sowjanya was an application development specialist at American Family Insurance. So welcome, and please take it away.
Thank you. Thank you, Richie. Hi, everybody. I'm Sowjanya Pandruju. I'm a cloud application architect at AWS, and today I'm here to talk about creating AI agents on AWS. So, uh, AWS AI agents represent a tectonic shift in how we build, deploy, and interact with intelligent systems. By leveraging serverless architectures and standardized protocols like MCP, the Model Context Protocol, and we'll dive into that in this presentation also. Developers can now create scalable, user-aware AI agents that seamlessly integrate with enterprise systems while eliminating all of the infrastructure complexity. So, um, technology advancements make AI agents practical for enterprise use. What does that mean? Moving agentic AI from buzzword to business reality requires four main or critical, you can say, building blocks. First, we need smarter AI models that can actually reason through complex problems and not just generate text. And second, agents must connect to real company data, your databases, documents, your systems, so that they can provide meaningful insights rather than some generic responses. And third, we need a very robust infrastructure with standardized protocols like MCP, the one I just mentioned, that let agents communicate securely and scale reliably across enterprise environments. And finally, we need sophisticated development tools that make it easy for teams to build, deploy, and also manage multiple agents working together, just like we do with traditional software applications today. So enterprise are doubling down on agents. In fact, Gartner predicts that over a third of all enterprise apps will be powered by Gen AI and Agentic AI by 2028. At least 15% of work decisions will be made autonomously by Agentic AI by 2028, as compared to 0% in 2024. Also, by 2028, one third of interactions with Gen AI services will invoke action models and autonomous agents for task completion. So you can see this evolution isn't just a roadmap for the future, it's already happening today. Now let's talk about this agentic system. So think of agentic AI like upgrading from a basic calculator to a smart personal assistant. Instead of just answering questions, these AI systems can actually think through the problems. They can make plans and take actions to get things done. They're powered by the same smart language models, but now they have memory so they can remember what you talked about, planning skills so they can break big tasks into steps, and the ability to use tools like booking systems or databases. And here how it works. So imagine you ask the AI to book me a business trip to New York. And the AI thinks about what it needs to do. It checks your company's travel policy, looks up flights and hotels, compares options, and actually makes the bookings. And doing all of this, it will keep you updated as well. So this happens in what we call an agentic loop. The AI keeps thinking, acting, learning from the results, and adjusting its approach until your trip is fully planned. It's like having a really smart assistant who never gets tired and can work with you and your business systems all at once. So, very interesting, right? So, let's dive into the real technical details of this. Strands agents. So, Strands agents is an open source Python SDK for building agents and with just few lines of code. So think of Strands Agents SDK like a toolkit that makes building smart AI assistant as easy as building a regular app. Like instead of spending months figuring out how to make your AI remember conversations or connect to different systems or think through complex problems step by step, Strands does all the heavy lifting for you. It's like, think of having a pre-built foundation for your house. You just focus on designing the rooms, like that's your business logic, while the framework itself handles the structural work, plumbing, electrical, all of that. So it takes the heavy lifting away from you. And the best part, since your AI agent is just a Python app at its core, you can run it anywhere. For example, Amazon serverless Lambda functions when you want to save on money, or if you want more horsepower on a powerful cloud container, or even on your laptop while you're testing. So it's like writing a mobile app that will work both on like iPhone and an Android without any extra work. And that's the kind of flexibility we need when you want to start small, test your ideas locally, and then scale up to handle like thousands of users without rewriting your code or enhancing your code, or deal with all that. So in this webinar also, I'll show you how to deploy your agent on Lambda functions, which automatically scale up and down based on your demand. So now let's get into this. Um, yeah, the strands. So strands implements what it's called an agentic loop that we just talked about, and that forms the core of its functionality. So the model receives a prompt and a context along with descriptions of available tools. Um, the model then reasons about the tasks and decides whether to respond directly in a natural language, reflect on its previous actions, plan like a series of steps, and also see if needs to select or use one or more tools. So when the tools are selected, Strands executes them and returns results to the model. So this loop continues until the task is complete. So now we talked about like strands being the Python SDK and very easy to code. So let me show you a simple example of building your first serverless AI agent. So here in the snippet, you are seeing the Python code, and it looks very basic, but it's pretty powerful. So imagine you're building AI-powered corporate travel assistant on AWS, and that's exactly what we are going to do in this webinar also. And let's say you have the following technical requirements. You define a system prompts, model you want to use, integrate tools for API calls, like business logic, knowledge bases, and you want to ensure proper authentication and you have proper observability. And Strands SDK handles all that heavy lifting for you. So you can focus on building smart, responsive agents with very minimal overhead. So in this code snippet, it creates a simple agent according to your configuration. That's it. Your agent now has a personality, it has a memory and ability to use external tools. The agent class in Strands SDK abstracts all of that agentic logic, like maintaining conversation history, handling LLM interactions, orchestrating tools and external knowledge sources, and also running the full agentic loop. So pretty powerful, right? And through this conversation, I talked about like how AI agentic AI needs to remember the conversations, the history, all of that. Let's dive into that a little bit. I want to explain how important it is to have proper session state management. So think of session state management like giving your AI agent like a notebook to remember conversations. Without this memory, every time you talk to your agent, it's like meeting a stranger who has no idea what you discussed 5 minutes ago. Imagine calling a customer service and having to re-explain your entire problem every single time. That's what happens without a proper state management. Here's the challenge. Like we talk about AWS, right? AWS, especially AWS Lambda, they are designed to be forgetful. They start fresh each time to handle millions of users efficiently. So we need to give our agent an external memory bank, like storing conversation notes in Amazon S3. It's like think of having sharing filing cabinet that any customer service rep can access to see your full history, so you don't have to repeat yourself all the time. And when you start a new conversation, the agent can quickly read through your previous chats from S3 and get up to speed and continues where you left off. So That's exactly what happens with Strands SDK. This is all happening automatically. The agent saves your conversation after each exchange and loads it back up when you return, creating a very seamless experience where your AI assistant remembers everything about your projects, about your preferences, and context. Each user gets their own private conversation history. So your travel booking discussions can stay separate, let's say from your colleague who's also interacting with the same system and he's dealing with expense reports. So it's totally private and it will have all of your history and, has the memory of everything you're doing. Pretty great, right? And now we are talking about all of this, and let's talk about how authentication and authorization play a big role in this. So, think of enterprise AI security like smart office building. You need your agent needs to understand, it needs to know who you are and what you're allowed to access before it can help you. It can't just give you out all of the information without checking if you have access to the system, or if even if you have access to the system, what level of access do you have? Like, let's say you are a corporate employee, like, and you have a badge. Your badge can get you into certain floors but not to like CEO's office, right? So your agent needs to understand your role, it needs to understand the permissions before booking that expensive first class flight or accessing sensitive financial data. And AWS makes this easy with the three-layer security system. So what you're seeing here, you have Amazon Cognito acting like it's the front desk that is validating your identity. And then API Gateway, it's like the security checkpoint. It has an authorizer that will validate your access level. And we have IAM policies that act like a rule book that defines which actions are allowed. When you log in, you get a JWT token that tells the AI agent exactly who you are and what you can do. This way, let's say a marketing team's AI assistant can book standard hotel rooms, but let's say you are an executive team's agent, you can have access to some premium options, and all automatically updated based on, all of this is done based on your role and policies. So that's the kind of power that we want to leverage. Um, Next. So we talked about MCP. What is Model Context Protocol? So Anthropic designed MCP to standardize the interface between AI assistants and data sources. Anthropic announced, I think, MCP's release in November 2024, and it provides a formal specification and SDKs for developers to leverage this concept. So how does it play with us? So integrating with remote servers. So as I mentioned, right, it's a protocol, and think of MCP like a universal remote control for your AI agent. So instead of building every possible tool directly into your agent, like hardwiring all of the buttons in a TV, MCP lets your agent connect to separate tool servers that different teams manage. It's like you have your smartphone and it connects to different apps. Your phone doesn't need to have every feature built in. It can have the apps, like, it connect to the right app when you need it. And here's why it's brilliant. Imagine your company, like it has a typical company will have a HR that is building employee management tools, a finance team with budgeting tools, and IT team with system and like monitoring tools. So with MCP, each team can build and update their own tools independently, while any AI agent in the company can use all of them through a standard connection. It's like having different departments run their own specialized help desk, but your AI assistant can have a direct line to all of them. This means your travel agent can check HR policies, and even monitor system health, all without the AI team having to build and maintain those specialized tools themselves. So this is how powerful it is going to be. And now that we have seen and try to understand the strands SDK, and we have seen this MCP, remote MCP service, now let's use all of this information and let's look into the code of how we can build an AI agent on AWS. And as I said, I'm using the example of leveraging AI agent that will book like flights or cars and hotels and stuff like that. So let's take a look there. Uh, so now I'm going to switch to the code. Now that we have seen this, let me. Oh, one sec. Yep. So I want to take you to this page. But so far, I just wanted to check, does anybody have questions so far? Oh, I'm sorry. Okay.
Oh, yeah. So there were just a couple of questions from the audience around pricing. So since we're using AWS, can you just talk through like how much it's going to cost to run the stuff we're doing today, particularly like around the pricing for Lambda?
Yeah. So the stuff that we are using is all of it is serverless, so it will deal with pay as you go. And for example, I can log into my screen, and if you're using a new AWS account, you will see that it has free tiers, and a lot of it is before you can actually hit any levels of cost. It will be minute. For example, I've been running this application past a few days, and this is a brand new AWS account that I have, and you can see so far it's only this much. And remember, when you follow along with me and you deploy all of this code, and towards the end I'll show you to destroy all of this so that you won't get charged more. But it's pretty minute. It should not, like, if it hits $10, that's pretty expensive. Like it's not even going to go there. So
Okay, so it looks like you spent 2 cents. So not free, but relatively cheap. Do people need to enter credit card details in order to make this work then? Or can you start without entering details, do you know?
yeah, I think you might need a credit card just on the paper when you're creating the account, as far as I remember. Um,
Okay, I guess if people get stuck, then I'm presuming it's going to prompt you to add credit card details if it's wanting you to pay. So, okay, if anyone gets stuck, then just let us know in the chat. All right, I'll let you carry on.
Sure. And that's a good call out, actually. I should have said something about that too. Yeah, you can see that this is all the things that I have been doing. And these are some of the things that will leverage today as well. We'll create API gateway, we'll have Lambda S3, and we are going to use Claude 3.5 Haiku version of Amazon Bedrock. And so far, it costed me 2 cents. And rest of the things I have not hit the limits on free tier yet. So, and I'm not going to, and I ran this exercise like at least 5 to 7 times so far in the past week. So, yeah. So let me, are there any more questions, Richie, or should I start with this?
Oh, actually, I just see one more question before we get going. So, Bharat Busan wants to know what's the difference between AWS Lambda and AWS Fargate. I've not heard of Fargate actually, so you just want to give us a quick overview of the difference.
Yeah. So Lambda is like, it's a serverless function, and Lambda in its own way, it will have a compute power, but it will have its own limitations. It can only run for 15 minutes, and the kind of memory you choose for a Lambda function will also determine the compute capacity that you will have on the Lambda. So let's say you have, and as a, and Fargate is also serverless, but it can run like a container, like you are using EKS or ECS. It will be a container, and it won't have those limits. it can use the kind of compute that you define. Like, let's say I want to build an enterprise grade, really intensive application that's receiving like 100,000 hits all the time, or it can be low also, like it's running all the time and it's doing complex calculations. And let's say I have some batch jobs even, like that I need to run like every day 30 minutes. Lambda can do that, and because it can only run for 15 minutes. But if I want to have the serverless technology, for example, in the containers also you have ECS, EKS, all these options, and you can use like a EC2 instance that's always running, or you can choose for a Fargate model. So with the Fargate, what you do is you don't have to maintain that server. It's completely serverless. You just specify, like this is my scalable policy. If the load is too high, scale up. If the load is too low, like this is the minimum number of pods that I want it to run, all of that configuration, and it does that for you. So Fargate typically handles all of the limitations that the Lambda couldn't. It's pretty more powerful without having to manage the server.
All right. So it sounds like Lambda is for kind of these sort of discrete computing tasks. So it's just running for a few minutes and done. And that's what we're using today.
Mm.
And if you need something to run for like a longer job, or you want more control over the computing requirements, then you can use Fargate. All right, super. Now, there are a few more questions, but I think we'll come to them at the end. So I'm going to let you get on with the code along.
Okay, yeah. So you can see my browser, right? The GitHub.
Yeah, we can see GitHub.
Yeah, sorry. So I hope everybody has access to this page. And this is a public repository, my own personal repository. And you should be able to clone this repo, or you can download if you're having issues with cloning. You can do HTTPS or SSH. Any of the options work. But I want you to, and there is a lot going on in this, and I have tried my best in documenting all of the details, what it's trying to do. So today we are going to create this AI agent that is a travel agent. And this, what it's going to do is it's going to book flights or a car or a hotel. And some of the for some of these tools, like I said, like booking a hotel or booking my car, I'm using strands. Yeah. MCP server. Let me take, yeah. So the tools, I want to talk about these. So within the agent itself, I have two of them. So one is get user location and get today's date. So these are running within the agent itself. But the big ones, like the different options that I'm trying, the get travel policies or get available cars, book a car, book a hotel. These are all the options that I'm providing in this AI agent, and I'm using the MCP remote servers to do this for me. So here is the architecture that we are looking at. So I have two fictitious users, Alice and Bob. And for the travel agent UI, I'm using Radio. And I have Cognito in place. So when I'm interacting with the UI, it will generate the Cognito will validate my authentication, and it will generate the JWT token. And when it hits the API gateway, the agent authorizer gets initialized, validates if I have right access or not, and that's when it hits the strands agent, which is running inside a Lambda function. And strands agents, it has its own session store. I'll show you. It is automatically baked into the agent itself. And then for Bedrock, for inference, I'm using Bedrock Claude 3.5 Haiku model. And for the specific functionality, like we're talking about, like getting travel policies, cars, all of this, I have a separate MCP server, and the strands agent is going to make a call, get that details and give me a response. So we have this option of deploying everything through Terraform or through CDK. And here's a quick overview of what I just said, and the authentication and authorization flows that we have. So Yes. As I talked about, the session is being managed by internally provided by Strands SDK, is the S3 session manager. And let's go into running the project. If you are on this page, this is where you will land. And these are the instructions that we are going to look into in running. So I'm using US East 1 as the region, and I want to have access to this model. So this is one thing to know. When I log into Bedrock, by default, you don't have access to anything. You have to go into this page. Let me make this bigger so you can have a clear view. Yeah. So this is the Amazon Bedrock service. Once you log into your console, you go to type in Bedrock, and it can take you here. So this is the overview. This is the page you land on. And here on the left nav bar towards the bottom, you see the configure and learn. Here you click the model access, and you can see that you can request access. So I was able to request the haiku. So I selected this. For example, if I want some other option, I would do click on it, and I would say next. I don't need this access now. I already requested access to this. I don't know, this will this. So whoever has access to AWS account, before we start running any of the infrastructure, I want you to uh, go here, go to model access, and click on here. And it might say, yeah, because I already have access, it's saying that. Let me try with a different one, just so I can show you how it is looking like. You go to this page. No, I don't want to remove access to anything. Yeah. I don't want to click submit because I don't want to remove access. This is what I'm trying to do. But you get the idea. So you come here, you do request access and submit. It will give you the access. It all happens within seconds, not even minutes. So you should be good to go. This is the only thing that I wanted to highlight. And once you have it, you will see that it is showing you like this, access granted. I'm saying this because this is the model that we are going to use in our code. So I can show you the VS code. Oh. Yeah. So if you see our this is not the right one. Yep. So if you go to the code, go into lambdas and agent config, this is where I'm saying which model to use. I'm saying Bedrock model and US East 1, and this is the model that I'm trying to use. So if you don't enable this, you will most likely run into error that your system doesn't have access to this. So let's get started. Let's follow through the instructions here. You have git clone. I already have cloned it in my local. I have it right here. So this is the first step that you need to do. And once you're here, I need you to run these dependencies, install these dependencies. Yeah, I'm gonna wait for you here, and I'm gonna take this into a new browser. Yep. So I can see what's going on in the chat also. Yeah. So you have two options here. Once you install the dependencies, it's the same dependencies for any way you want to run, like with Terraform or CDK. I'm running with CDK because I love CDK. It makes things easy. I get to see what it's doing, all of it in CloudFormation also. It generates a CloudFormation template for me. So I can debug what's going on. And Terraform is amazing in its own way as well. But that's why we have these options available. So once I install these dependencies, which I already have in my system, I'm going to go and I'm going to do the CDK deploy. So I want to show you the CloudFormation page also. So did I not? Yeah. So I already, and if it's the first time for you running this, you need to have something called, you need to run the AWS space configure. This is the command you need to run so that you can put your access keys and whatnot. Let me quickly show you. Um, yeah, to run your AWS CLI. So you need to be able to use this AWS. Yeah. So this is exactly it. So you will have something called AWS Access ID and Secret Access Key. So when you created your account, you might have access to the root user, but you have access to, and it's not a good practice to be using root user credentials. So the good way to do it is go to IAM, go to users, create an user. This is a user I created 3 days ago. And when I go in here, I have security credentials, where I have like access key, and I have one. When I generated it, gives me a secret ID as well, which I save it. So using that, I'll be able to log into the system. So that I'll be able to run all of the AWS commands from my local itself. So now that I have all of this code here, I'm gonna do CDK deploy. Looks like I have created it and have not. Yeah, I'm destroying my code live, and I'm going to show you how exactly and how fast everything gets built. So these are all the resources that I've created using this stack, and I'm removing all of it and doing a fresh build all over again. And everything that I have going on, I can see it in the CloudFormation. It's telling me what it's trying to do. So let me see here. Yeah, if I go back, I don't see it anymore. It's gone. So now I'll go and do CDK deploy, and it's gonna ask me, yeah, so these are all the things that I'm trying to create. So it's giving me a plan of, hey, I'm creating these lambdas, and these are Zoom roles for you. IAM policy changes, all of this. Do you want to deploy? Yeah, I do. So now it's going to create a CloudFormation change set, which I can go in, and if I'm curious about what it's trying to do, it's going to give me updated information here on the screen all the time, so that I can see what it's what resources it's creating. So see, S3 bucket for let me go here. Yeah. So it's creating S3 bucket for session storage. It's creating Cognito for user authentication. And it's doing a lot of these things. And it's creating the travel agent API, and it's creating the booking server, and I have authorizers, as I've mentioned. So everything, all of the infrastructure that you're seeing here, I'm able to see that happen, how it's getting created here in this CloudFormation stack. Yeah. So this shouldn't take longer than 2 minutes. Yeah. It's almost there. Out of 43 resources, it already created 39 of them. So it's almost there. It's finally creating the API gateway, and it's almost done. Yep. So here I can see that it's create complete. It was able to deploy all the things that I'm looking for. And I have put some outputs on what it's trying to create. So I have this agent API that it's going to call, and I have this Cognito client ID and Cognito authorization for creating the GWT tokens and all of that for me to log out, and I have all these in place. So now that I have the infrastructure deployed, I want to run this application. So to do that, and here I have a printable script so that I can have two users, Alice or Bob, um, and I want to run that system. So once I am done with CDK deploy, it ran without any error. Now I'm going to run this script so that it can create two users, Alice and Bob, with this password so that I can log in to the UI. So let's do that. So I'm going to do this. Yep. And this is creating the user and it is injecting into my web env. So now I can run the web UI, and these are the instructions that I'm going to follow. I'm going to go to and I'm going to create a virtual environment. Yep. And I'm going to activate that. Yep. And I have already done the installing of the dependencies, but it would just say they're already installed. Yeah, already satisfied. That's all. If it's you are running for the first time, it will just install all the requirements for you. And now I'm almost ready. Like I want to run the app. Yep. So this is running on my local host here. So I'm going to open localhost. The first thing it should be asking is me to log in. And I'm going to choose Alice to log in. So Alice and password. I have configured this to be my password. So I'm going to copy that and get in here. Yep. Now I'm in the system. So this is telling me this is my fake corporation. It's telling me, hey, welcome to this Acme travel agent. Yeah, so it's telling me how it can help me. So I'm gonna say something like, book me a flight to Chicago in 3 days. Yeah. And it should ask for more details at this point because I just said book me a flight to Chicago in 3 days. So this is where the calls are going to the backend. You'll see all the calls it is making. So you'll see that this is what I said, book me a flight to Chicago in 3 days. And this is the authorization token. I'm printing it just to show you that, the Cognito is able to authenticate, and it's also sending the JWT token for proper authentication authorization. And behind the scenes, it is doing all of this. Oh, I have a response back also. So here Alice is back. Sorry, I'm Alice. So here the agent is back, and it's asking that, asking for more information, like how many nights and what's the purpose, and what kind of a car do I want. And once I have these details, booking a hotel that comply with Acme's travel policies, because this is the specific company, and we have wanted certain compliance in place, and that's what it's talking to us about. So on a high level, this is how our agent is looking like. I do see somebody's asking for GitHub links. Okay, I think Reese has responded to that. So, any questions so far? Maybe I can look into the.
Sure. We got a few questions from the audience. Actually, so this first question, we sort of we missed it. It was a little bit late to answer as is, but so e-content, interesting name, is saying, do you build locally and then deploy on AWS? Is it better to like build on AWS to begin with? I know in this case, like we had a whole GitHub repo prepared. So do you just want to talk through in general, like what's your workflow for creating agents? Like what's the high level steps?
Yeah. So, in this sample, I had a full blown AWS example. Like, if you remember in these one of the slides I was showing you, you don't need to have run this on AWS at all. You can run all of this locally as well. For some of the inference, like I was using Bedrock, for that, you do need AWS. But without that big LLM inference, if you just want to use the strands agents and the remote server tools from the MCP servers, they all support local configuration also. You'll be able to run your application locally because the strands SDK, it's a basic Python SDK that gives you an agent all by itself. So you don't have to run on AWS. You can start simple, run everything. It's just that if you have any integration with AWS components, that's when you have to have AWS account and stuff like that. But otherwise, it's start locally, start small, and that's my suggestion as well.
Okay, that sounds sensible. To just start with the minimal amount of technology possible, just get something working and gradually build things up. Because I guess the tech stack for agents can become very complex. Like you can get a lot of different components in there. Actually, just on that note, I mean, because AWS has what, 250, 300 services or something now. Are there any services you think people should be aware of that aren't? Like, what's your favorite service that no one knows about?
That's a cool question. I think I like what everybody likes. Also, currently, I'm a big fan of Bedrock and the amazing things that it's doing. There is still a lot of untapped unknowns in how much it can do. A lot of awareness is needed. Even I'm learning as I'm going. Like this year has been my journey in getting into AI and seeing how what LLMs can do for us. But there's more coming, and like in less than a year, I can see like kind of this webinar but doing really cool stuff here. What I'm doing, a simple travel agent, but we could do like a lot more in a really with very less code as well.
Okay. All right. So Bedrock is. So it sounds like Bedrock is kind of the flagship platform for anything generative AI. I guess SageMaker was the previous platform for AI stuff. Do you want to talk about through like when you want Bedrock, when you want SageMaker?
Yeah, so Bedrock is all like and even like but it's the LLMs, like if you want to deal with, or like I'm going into the console right now, you have all the foundation models here. Like you can directly, if you want to not build anything but just test out, like to identify, hey, what are different models here, what do I like my use cases. I have image generation, or I want to just have a chat bot or stuff like that. You get all of that here. Like you can go in and you can select a model, anything. These are all the options available in Amazon right now in US East 1, and you get to talk to all of that, see and do all that. But SageMaker is a great tool. It gives you a full-blown area for your analytics. This is where you actually build stuff. So yeah, now we renamed it to SageMaker AI, but this is where you build your models, you train them, you do a lot of stuff. And then if you want your custom models, this is where you come, you create all of that, and then leverage those models through Bedrock.
All right. Okay. So you do well, I guess any predictive like machine learning, or if you want like you want to fine tune a model, do that in SageMaker and then pass it over to Bedrock for your chatbot. All right.
Yeah. So
Okay. Nice. Oh, sorry. Do you have something to add or?
no. So if you we are trying to at Amazon, we are trying to get a lot of information right away when you log in also. So if you see, there is so much information everywhere, but we are trying not to be too pushy on the documentation either. So yeah, so here it's trying to say this, like, hey, this is what it's trying to do. But this is a new thing coming up, the SageMaker AI. Even this service is going through a total revamp, and it's going to do amazing stuff than what it has been before, because SageMaker has been here for a very long time. This was before Bedrock also came in. I think even I'm excited to see what SageMaker AI has in store for us. But SageMaker, in the past, people were able to leverage this. If you have a lot of data coming in and you wanted to do some understanding over that, people at enterprise level were able to leverage SageMaker and create their own flows, understand and train their models using lots of varied enterprise data and stuff.
Okay, all right. So we'll watch out for SageMaker AI then. Is that coming? Do you know when that's arriving? Or is it here already?
It's here. So this is my personal account, and here they have an updated model for SageMaker. Yeah, I think there's more coming in the future also, but this is like it makes it even easier for you to train your models. Yeah, and it gives you the whole pipeline, like build, train, and deploy.
Okay,
So
all right,
make
super.
it
All
easier.
right, we got a ton of audience questions now, so let's go to some of those. So Mark asks, it's about what's the relationship with LangChain? So LangChain is it's an AI development framework. So you got LangChain, and you got a few others. There's Llama Index. You've got Haystack. There's a few of these. So where do those AI application development frameworks fit in on the AWS platform?
Uh, See, there is no limit. A lot of them fit on the platform. If you think about, and that's where it's evolving also, right? If you see the models also, you'll find every single model available today. These are all the models, and even the frameworks we have. Continuously evolving. I don't know the comprehensive list because it's just too many. I have to look what's not supported at this point. So
Okay, all right. So yeah, I guess most of major frameworks are going to be supported at some point, even if they're not already.
and even for things that you might think they're not supported, there always will be a custom solution that you can work into. So that's the beauty that this platform provides. Yeah.
Okay, wonderful. So next question comes from Krishna. Hi, Krishna. He's one of our regulars. Krishna says you mentioned memory. How long's the memory of these chatbots? And I guess there's two things, right? There's like how much memory do you have within a single conversation, and then what happens if you just leave the chat and you come back like next month? So there's like that between session memory as well.
So you specify what kind of, for example, in this sample we have been leveraging Lambda, right? So and this is great for this use case because I wanted to go with the paper pricing model, and one second. Yeah, this is my travel agent on Lambda. I just want to show you how I have this set up. So right now I've used this much for my Lambda function, and my performance depends on the memory that I'm giving. Because let's say if I'm asking a very complex setup, and if the model has to go through that agentic loop multiple times, it needs that capability to run that multiple times. And if I'm asking, like, it depends on my prompts too, right? Like if I'm doing very basic prompts and the model is like, okay, it immediately comes back with another question. Their memory usage is low, but I'm being very specific and I'm saying, hey, this is all I want. My question to it is very specific, and it's asking the agent, do this first, then use this information, and do this next. It's going to pull a lot more because it has to make multiple calls to different tool servers. Let's say in the same prompt, I'm saying, book me a flight, but then I want this hotel accommodation, and to there I want this car. In the same prompt, I'm asking for 3 or 4 different MCP tools, and it has to go through all of that because it has to keep a track and give me a comprehensive answer. That's when it's going to spike up the memory usage. And the more complex and more intense your model is, and the more amount of memory it's taking, your performance is going to take a hit. Let's say I have a really critical agent running on a Lambda function, and I have given it very little memory. Let's say I have given this to be like 258 or something. It's going to struggle. It's going to be like give up, and it's going to say, oh, something's happening with me, bear with me, or it's going to time out. So depends on your use case. The more intense your prompts are, the more memory usage it's going to need. And that's when you switch to a more horsepower. I think that's the term I used in the past, to a container based like application. Yeah.
Okay, so I guess like in theory, you've got effectively infinite like computational power available to you. It's just a question of like playing around with how much do you need, what's the minimum you can get away with in order to run your application and still provide a good user experience. Okay, wonderful. So I think this next one is actually probably a question for me. So South Fluff Girl 76 says, I presume that's Florida, I'm guessing. So what's a great DataCamp course for beginners with AI agents? So if you've got a background in data, but AI agents, so your first thing, we actually have a course called Introduction to AI Agents. So that's the place to start. That one is no coding required. So that's like where you go through the fundamentals. In terms of sort of extended series on developing with AI, we've got a whole track of multiple courses called Developing Applications with LangChain. So like a sort of most extensive stuff is on like using LangChain in order to like build these things. We've actually started branching out into other technologies as well. So there's a course on building AI agents with Haystack. There's one I can't remember. There's courses on like LangGraph. There's stuff on I can't remember what the agent development kits, Llama Index. So basically, you've got a choice of different technologies. At the moment, LangChain's got like the longest series, but we're kind of working on building everything out. And then there are tons of courses on AWS as well, but depending on which services you want. So Introduction to AI Agents is where you begin. And then, yeah, do take a look at developing applications with LangChain if you want like a more extended series for now. All right, super. I hope that answers the question. Basically, there's tons of stuff. All right, so next question. I think this might be a little bit tricky to answer. It's like how long is a piece of string? So suppose you want to deploy this, keep it running. Maybe
Yeah.
I don't know whether you can give sort of finger in the air costs or whether it's worth talking about like the tools you have for monitoring and controlling costs on AWS.
Yeah. So it depends on the usage and how much you're using. And one amazing thing AWS does for you is it gives you this cost explorer. So it can give you a clear breakdown on how much things cost for you. And they also have a really beautiful page for pricing for every because my usage is so low, it's not showing me anything even though I've been using for the past nothing here. But this is where you will be able to see all the stuff that you are able to look into, like how much each thing costs. But so for example, here I'm using free tier offers, and this is what it's telling me. Like, this is what I have done. I have created. I've used KMS. I have used Lambda function. I have used CloudWatch. All of that, but I'm still in the free tier, so that's why none of that costs me. But let's say you have CloudWatch that you want to understand the pricing for. So you have this nice math-based page where you get to understand how the pricing works. And it also depends on the region that you're using. It's not a big difference, but that also significantly comes into the picture. And it talks about examples, like how detailed it needs to be. Like if you are looking at installing EC2 and having a detailed monitoring, this is how it looks like. But even with all of this, if you think reading is difficult for you, like it's too much information at one point, you can always do this live chat, and this is amazing. I love AI everywhere. I stopped reading tons of documentation anymore, and I just ask, like how much does this cost and things like that. But it gives you a really good understanding on calculating. For example, right now I'm in this calculator for CloudWatch. Every service that you work with will have this AWS pricing calculator that helps you determine with your best efforts, like what you're trying to do. As I said, region plays into the factor. And then it high level asks about what are you trying to do. You can give some basic info, and it will give you a nice clear estimate. You know what you're walking into, like how much it's going to cost you and stuff like that.
All right, wonderful. Yeah, I think nobody wants to be surprised by a giant AWS bill, so it's good that you can set limits on what you're doing and just monitor what's happening. So yeah, CloudWatch in particular seems a very useful tool there. All right, so we are at time. Before everyone dashes off, I want to say, if you have not registered for Data and AI Literacy Month, please do so. So that's going to be a series of 13 webinars throughout September, all on data literacy, AI literacy. So it's like everything you need to know about data and AI, even if you don't have data or AI in your job title. So we've got a ton of great speakers, ton of great sessions. Please do make use of the link to sign up for that. So links in the chat. Also, before we get to that, on Thursday, we've got a session on using computer vision AI. So computer vision AI is one of those things where I get really excited about its value for business, but it's not as hyped as much as generative AI, I think. So computer vision, well worth learning about. Please do come for that on Thursday. So with that, so I just say thank you so much, Sowjanya. That was like an amazing session. Yeah, really enjoyed that.
Thank you. Thank you. I've enjoyed this conversation, and the folks have been so nice too, like asking the right questions. Such an amazing session. I loved it through and through.
Wonderful, yeah, very much agreed there. Great audience, lots of really thoughtful questions. So yeah, very impressive with those. Well done, audience. So that was wonderful. Thank you to everyone. Thank you to everyone who showed up today. I'll see you all again soon.